In part A of question 3, they ask you to write an equation for the line tangent to the graph of f at x equals 1/2. So we'll look at the equation f of x, which is 8x cubed. Then you find the derivative of that, which is 24x squared. Next, to find the slope, you have to plug in the x value, which is 1/2, and you get 6, which is your slope that we're looking for. Then with that, we have to find the equation, and we know the x and y coordinates from the graph given in the equation right here. Then from those points, we plug it into the y equals mx plus b equation, and you get the y-intercept to be -2. Then you plug that back into the y equals mx plus b, and you will get y equals 6x minus 2 to be your equation. Or you can also do y minus 1 times your slope, which is 6, times x minus 1/2. This -1 is from the y value at this graph point, and the 1/2 on the x minus 1/2 is also the point from the graph. Now let's award points. Part A is worth a total of 2 points. There's 1 point given for finding what the derivative of f of x at 1/2 equals. So finding this slope is worth 1 point. The other point is given to you by the correct answer, which could be either of these forms. Now in part B, we must find the area of R. So what I did first was I labeled the upper line in the graph to be capital R. The equation is sine pi x, or g of x. Then I labeled the lower line, or the bottom line, to be lowercase r. That's also f of x, the equation, which is 8x cubed. Now to find the area, we must do an integral. So I did capital R minus lowercase r with the integral from 0 to 1/2. Or you can rewrite that the area equals the integral of 0 to 1/2 of g of x, which is the upper, minus f of x, which is the lower, dx. This integral is then rewritten, plugging what the equations equal into the integral. So it's the area equals the integral of 0 to 1/2 of sine pi x minus 8x cubed dx. Then you find the antiderivative of that, which is -1 over pi cosine pi x minus 2x to the 4th. And this 1 over pi is chain ruled from the inside. So to get rid of that chain, we have to put 1 over pi. So now that we know the antiderivative equation, we must plug in 1/2 and 0 and find the difference between the two. So what I did first was I wrote the equation plugging in 1/2, and you'll find that value, and then you'll subtract it from the value that you find from plugging 0 into this antiderivative equation. From there, you'll get the answer, the area, which is -1/8 plus 1 over pi units squared. Or you can also find the decimal value, which is the area equals 0.19331 units squared. And you want to make sure that if you're going to put the decimal form as your answer, you must round to the nearest 1,000th place or farther. Now we are going to award points for part B. Part B is worth a total of 4 points. 1 point will be given for the correct integrand, which is right there. Then there's 2 points given to you if you have found the correct antiderivative, which we found right here. And the last point will be given if you have the correct answer, which either of these forms will work and be correct. In part C, it tells us to write but do not evaluate an integral expression for the volume of the solid generated when r is rotated about the horizontal line y equals 1. So when we're first looking at this here, I just drew out a picture to see what it kind of looks like. So here's y equals 1, and then it's going to be rotating around it. So I kind of just drew what a different angle of that would look like. Here's it's rotating around the y equals 1 line. And so we have to remember that for the area of a circle is pi r squared. And then we're going to plug that into the integral. So right now what I wrote down was pi times the integral of 0 to 1/2 of lowercase r squared minus uppercase r squared dx. And what we're doing here is the lower r is farther from the y equals 1 line. And so we're going to have that first subtracting this distance between the uppercase, the capital R line. Now an important thing to remember is this pi times the integral of 0 to 1/2 lowercase minus uppercase r squared is not correct. We cannot do that form because what this basically is saying is that there will be squares coming out of the page on each of these intervals, which is not what we're doing. We're trying to rotate it around, so that will not work. So what we have so far would be perfect if we were rotating this area, capital R, around the x-axis, y equals 0. But that's not what they asked us to do. They want us to rotate it around y equals 1. So what we have to do is, in our integral, add the 1 minus the lowercase r and 1 minus the capital R, and then square each term. So far, we have pi times the integral of 0 to 1/2 of 1 minus r squared minus 1 minus capital R squared dx. And the last final step that we will use is to plug in the equation of lowercase r and the capital R. So the final answer here that we've laid out is pi of the integral 0 to 1/2 of 1 minus 8x cubed squared, that whole term, minus 1 minus sine pi x squared, that whole term, dx. And that is your final step to what they're asking you to do. Now for awarding points. Part C is worth 3 points total. 1 point is for finding the correct limits and constants. So right over here, this right there will give you 1 point of the 3. And then they're going to award you 2 more points for finding this integrand right here.